Hey guys, it's Miss Nelson. Today you're going to be doing notes over writing equations from graphs. So we've previously done them from tables. So now we're still going to have tables involved in these, but the tables are going to help us create a graph that then we can then also create an equation for. So it says, remember that we can use points from a graph to create a table or vice versa. We can go from a graph, pull out the points that are listed, and put those points in a table. So it says Angie's walking speed is 5 kilometers per hour. And May's walking speed is 4 kilometers per hour. Use tables and graphs to show how the distance each girl walks is related to time. Okay, so we know that if Angie's distance is 5 kilometers per hour, then we know that from here to here, we increase by 5 and then 5 again. So for 3 hours, it's going to be 15, and for 4 hours, it's going to be 20. Okay, so that is Angie. May has the same relationship, except that hers is 4 kilometers per hour. So we see we increased by 4 on our y values over here. So instead of 8, 3 is going to be 12, and 4 is going to be 16. So each one, on our top, we multiplied by 5. On the bottom, we multiplied by 4. Okay, so we completed the table based on the relationship it gave us. Okay, B says for each girl, make a graph showing her distance y as it depends on x. Plot points from the table and connect them with a line. So all I'm going to do is I am going to plot points based on the table. So if I start with Angie, her first point was 0, 0. So I put a point here at 0, 0. Her second point was at 1, 5. So I know my distance over here is counting by 2s. So I know that the hash mark between the 4 and the 8 is going to be 6. So for 1, it's going to be partway in between here. And your line should be a little bit clearer because, you know, my graph's a little bit bigger. 2 is 10, so I know that hits exactly at that hash mark. 3 is 15, so again, it falls in between. And then 4 is going to be 20, so again, it meets at the top. So I'm going to connect them with a line. Okay, so for May, we're going to go back to the table for her. Her first point is at 0, 0. Her second point is at 1, 4, 2, 8. So you see her numbers line up a little bit better. 3, 12, and 4, 16. So if I connect her dots with a line, you see that they are both linear and they both go through 0, 0. So we're going to write an equation that represents each girl's relationship. So for Angie, I know that if I increase by 5 each time, I can say that y equals 5x. And for May, she increased by 4 each time, so I'm going to say y equals 4x. And it says, how can you use the tables to determine which girl is walking faster? How can you use the graphs? So for the table, if you look up here, back up at the top of the table, if I choose the same exact x value, so for example, 1 and 1 in each table, I see that Angie goes 5 and May goes 4. So since the x's are the same, I can use the y's as a determination. So I look at the same x value in each table to see which one is higher. So for tables, we are going to look at the same x value, and I'm putting that in quotations because it didn't have to be 1. It could have been 4. We could jump ahead to 50. It doesn't matter. In each table, and compare y's. Again, I'm putting them in quotations because those y's are going to be different. The graphs, if we look at the graphs, even though they both go through 0, 0, what we're going to be learning about graphs is the steepness of a graph. If it is closer to this y-axis right here, or if it is further away. The closer to the y-axis you have, it's called a steeper slope, which means that your gaps between points are farther apart. Okay, You see that this one here on May, she's a little bit further apart from the y-axis. So on our graph, sorry guys, you know how that likes to show up. Okay, so let me go back. Let me add that A. Let me change the colors again. So on a graph, look at the steepness. Okay, and we're going to be doing more work with graphs to be able to determine, which is steeper and things like that. But that is one way to determine on a graph who travels at a faster rate. So let's go ahead and let's look on the second page. It says that Sharice pays the entrance fee to visit a museum, then buys souvenirs at the gift shop. The graph shows the relationship between the total amount she spends at the museum and the amount she spends at the gift shop. Write an equation to represent the situation. So what we're going to do, we're going to walk through here. So we're going to read the ordered pairs from the graph, and we are going to put them in a box. Okay? So our first point is at 0, 5. You see there is not a point here at 0, 0, so it goes up at 5, again counting by 4s. So even numbers are going to hit between the hash marks. 5 was at 10. We know halfway between 8 and 12 is going to be 10, and 10 appears to be at 15. We know that 15 again hits right here. 15 is at 20. And we have one last point way up here. So if we follow it down, it hits a little bit there. And now what's tricky about this graph, okay, you kind of got to look at it just a little bit. My numbers seem to be pushed a little bit on the view up here. It lines up a little bit better. So my X is 22. It's a little bit harder to see on your paper. They've all kind of shifted. But my Y is going to be partway between 24 and 26. So that's going to be 25. You know what? And I'm sorry, guys. It shouldn't be 22. Let me go back. It is not as clear over here. So what I want to point out here is that, see if I can't get this line right here, this 20 should actually appear right here, which means that everything is kind of shifting a little bit over. So excuse me, that is not going to be 22 because it doesn't match the pattern that everything else has followed. And I'll show you what I mean in just a minute. This should be 20 because from here, I'm adding 5 each time. So to remain constant, I would add 5, not 7 at the end. Okay? So sometimes you've got to pay very close attention to your tables when you are, or your graphs when you're reading them. So what is the pattern in the table? So my pattern, remember, you're always looking from your X to your Y. So what is happening between each one of these? So it appears that if I'm starting at 0, I can't multiply 0 times anything and end up getting a 5. The only way I can get a 5 is if I add 5 to it each time. So my equation is going to be y equals x plus 5. Okay? I'm sorry, so we should move that down. So I'm just going to put that equation into words. So what we're going to put in words is that you add 5 to the x each time. And remember that x is a placeholder. So we're going to identify the independent and dependent qualities. So if you were like me and labeled your x and y on top, my independent variable is going to be my gift shop amount. My dependent variable is going to be my total amount because the total depends on how much you buy in the gift shop. E says draw a line through the points in the graph. Find the point that represents Sharice spending $25 at the gift shop. Use the point to find the total she would spend if she spent $25 at the gift shop. Then use your equation from C to verify your answer. Okay, so I'm going to come back up here. Okay, so I'm going to connect all these points right here, form a line. So it wants to be at 25. So it's kind of hard to tell, but 25 is going to be right here because remember this 24 should be there where that line is. So if I track it up, it's going to hit about right here on this line. Okay, so it looks like on the graph it appears to be at 30. Oh. I hate when that happens. I wish we could figure out a way to fix that, but until we do, we just gotta do it. Seems to happen more and more, it seems like. Okay, so on the graph, it appeared to be $30, but now we're going to prove it with our equation. If our equation was y equals x plus 5, and it tells us that our x is going to be our 25, I'm going to make it a 25 plus 5, which does in fact equal $30. So this equation right here proves that that is our relationship and that you will get an outcome of $30 if you spend 25. Okay, so make sure if you have any questions, you come tomorrow ready to ask them. Have a good day.